Dear students and friends, in this video I am going to discuss a problem from the friction topic. The problem is something like this. Two blocks connected by a horizontal link AB are supported on two rough planes as shown in figure. The coefficient of friction for the block on the horizontal plane is 0.4. That means for this block, the coefficient of friction is directly given, that is 0.4. The limiting angle of block on the inclined plane is 20 degrees. For the block B, the limiting angle is given as 20 degrees. From the limiting angle, we can get the coefficient of friction for block B, that is tan 20. What is the smallest weight W of block A, which will keep the system in the equilibrium if the weight of the block B is 5 kilonewtons? If you observe the direction of motions, this block B tend to move in the downward direction. That is the tendency, because this is the inclined plane, this will tend to move in the downward direction. So that's why the friction force must act in the upward direction. As it is moving in the downward direction, this block A will move towards your left hand side. That's why the friction force will be towards your right hand side. The equilibrium position means this block B must stay at the same place. This block A must stay at the same place. There should not be any movement. Based on the tendency of their movements, we will decide the friction force. This is tending to move downwards. That's why friction force is in the upward direction. As this is moving the downward direction, this particular link will push block A. This will move towards your left. That's why friction force must be in the towards your right hand side. Suppose it's not tending to move. That means this block A is exerting some force on block B. That force will act on this through this particular link AB. Okay. Now identify the angles and identify the reactions. The force on block B due to self weight will act in the downward direction, that is 5 kilonewton. Then this is the horizontal direction. The angle made by this inclined plane with respect to horizontal is 60 degrees. The normal reaction is perpendicular to this inclined plane, that is NB. As it is sliding down, the friction force will be in the upward direction, that is mu NB. If you take the horizontal plane here, this angle is 60 degrees, this is 90, automatically this will become 30. To keep the block at this place, we are exerting some force from block A through this link. That force is T. As the block B is moving in the downward direction, the block B will exert some force on block A. That force is again T. That is the force acting on this particular link. This force T is transferred from block A to block B through this link. Okay, that's why we have shown this on both the blocks as equal and opposite force. Then W is the weight of the block A that is acting in the downward direction. Because of that, normal force NA will act in the upward direction. As the block A is tend to move towards your left hand side, because as it is sliding down, this will tend to move towards your left hand side. Friction force will be towards your right hand side, like this. U and B will be towards your right hand side. Okay, these are the directions of all the forces. Next, find the coefficient of friction for block B, that is mu tan 20, that is 0.36. Now draw the freeboard diagram for block B. Just remove all these supports and show only the forces and actions acting on the block B. That means this 5 kilonewton in the downward direction, NB at 30 degrees angle, mu NB at 60 degrees angle, and T in horizontal direction. These forces we have to show like this. Remaining all the supports you remove. Now apply the equilibrium equations. Now take sigma Fy equal to 0. Then this 5 kilonewton force is acting in the downward direction, that is negative. NB is making 30 degrees, means its y component is NB sin 30, that will be in the upward direction, that is positive. Mu NB sin 60, that is again in upward direction, that is positive. This is negative, like this. NB. This angle is with respect to horizontal, with respect to x-axis. So that's why y component will be NB sin 30. This is making again 60 degrees with x-axis. That means mu NB sin 30 is the y component. These are upwards. This is downwards, minus 5 equal 0. From this, mu value is known. Only NB value is not known. That NB value you can find like this. Substitute all the values. Sin 30, mu 0.6, sin 60. Only unknown is NB. You just add them. Then find the NB value. NB value equals 6.15 kilonewton you will get. Take sigma Fx equal 0. Then this T is acting towards your positive x. Then mu NB cos 60 towards positive x. NB cos 30 towards negative x. Minus NB cos 30 that is negative. Mu NB cos 60 that is positive. Plus T you will get. This is T plus T you will get. Like this you will get plus T. Then here NB value is known. Only unknown is T. You can get the T value. So here you have to write not minus 5 plus T. Now T value you are getting as 4.22 kilonewton. Now take the free body diagram of block A. Now this T value is known. Mu value is given in the problem 0.4. Now consider the free body diagram for this particular block A like this. Remove all the supports and consider only forces acting on block A. Now if you observe the vertical direction, NA is acting in the upward direction, W is acting in the downward direction. Then here mu NB is acting in the right hand side, that means positive x. T is towards your left hand side, means negative x. From sigma Fx you can get the NB value. Here T value is known. Here T value is known. Now take sigma Fx. This is not NB, this is mu NA. Mu NA that is towards positive x minus T is equal to 0. T value is known 4.22. Mu value is known. From this you can get NA value. NA value you are getting as 10.55 kilonewton. Okay. This is mu NA. Now if you take sigma Fy equal to 0, this NA upwards positive, W downwards negative. That means NA minus W equal to 0. NA equal to W you will get. NA equal to W means already you know the NA value. You substitute that NA value. W equal 10.55 kilonewton you are getting. So the weight of the block A is 10.55 kilonewton to maintain the equilibrium. In this way you can solve the problems related to equilibrium position of blocks. Thanks for watching this video. If you like this video, please subscribe to my channel.